Good afternoon, everybody. First of all, I'd like to thank the organizers of this event to invite me to talk to you and introduce briefly my company, LASHARE, and to explain you also briefly what is our activity within the LASHARE project. So this is the content of the presentation. I'll show you in a couple of slides what is the activity LASHARE does. I hope it's clear enough to explain that. And then I will pass to introduce you the objectives of the assessment in the one we are participating with several other partners that forms part of the LASHARE project, whose name is Flexible Jigs PV Scribing, FCPS abbreviated. And I will come in more detail to the participants in this assessment. So LASHARE is a SME. We have talked a lot about SMEs today. So LASHARE is an SME, a high-tech SME, based in Belgium, and whose specialization is the development of application and engineering solutions, mainly in the laser microprocessing field. So, and for that, we have a team of highly qualified team of mainly engineers, 39 in this moment, for the development of applications and processes, design and production of laser systems. Some R&D activity that I'm in charge to coordinate, and of course, some commercial and maintenance of the installed equipment. So when we talk on laser microprocessing, we are mainly working on laser marking and traceability. And for example, in this picture, we can see a very special marking inside a glass that is quite successful in the pharmaceutical industry, and by the way, was a result of a 6th framework program European R&D project. We have been also very active in the polymer welding by lasers since many years, but the line of activity that is more successful in this moment for us, without forgetting the other ones, is the laser micromachining, especially thanks to the femtosecond technology, as explained by Ulrich before. And all is working around our dedicated software that is able to handle with very complex configuration of systems, with very complex 3D designs, and also gathering data from the process itself with a very complex sensor like confocal sensors or vision systems. And we do all this integrating many different types of laser systems from CO2, solid state, fibers, or femtosecond. So, as I said, our objective is to provide solutions based on laser, mainly on microprocessing. That means usually a reduction of waste cost and an increase on quality, flexibility, and safety. And we do it going from the development of prototypes and pre-series, or process development and validation, passing by the development of OM equipment or workstation, and going even to the offline or inline integration of these equipments. In general, a laser system for materials processing is integrating three basic elements: the laser source, an optical system, and a positioning system. But depending on the application, depending on the laser source, etc., this can have very, very different configurations. And here you can see the range of our more serial machines that can go, well, from outside, that can go from a very little tabletop marking system up to a very large machine for example, the photovoltaic industry that is able to process very big parts with very high accuracy. Now I will pass to the assessment. The name of the assessment is Flexible Copper Indium Gallium Selenide Photovoltaic Scribing, and well, this is the jigs. And the status of this technology in this moment, in case of flexible substrates, are two situations: when when we use transparent polymeric substrate, or when we use thin metal sheets. In the first case, the problematic from the processing point of view is not different than when processing the glass, because we take the advantage of the transparency of the substrate. But in the second case, this is not the case, and we have to overcome several issues that are related to the thermal damage of the films, and well, need to handle with a more special care. In this moment, the best results are achieved with picosecond and nanosecond lasers, and mainly in the green, but also in the infrared wave lenses. And the objective, the global objective we want to achieve with this assessment is to go from a technology that has demonstrated to work well in the laboratory level, let's say, so have a technology readiness level of 6, up to a factory, to a TRL 7. And for that we have several sub-objectives that are related to the 3 laser processes, 3 laser applications that are related to these applications, are the P1, P2, or P3 processes, the spray patternings on this type of photovoltaic technology. And in case of the P1 here in the drawing, the objective is to remove the molybdenum, that is the layer, metal layer that makes the back contact, electrical contact in the system, to ablate at a speed of 2 meters per second with width of lines of 50 microns, and to achieve a perfect isolation, electrical isolation of both parts. For the P2 is the second step for the laser processing. The objective is to remove the functional material, the jigs, that is deposited above the molybdenum layer with similar widths of 40-50 microns, in parallel to the previous process, to the P1, at a distance of 50 microns. And the transverse resistivity of the result have to be in the order of a few mega ohms, so quite low conductivity. And in case of the P3, that is the latest layer, the transparent contact layer, the objective is to process as fast as possible. We expect to be in the order of the P1 process, and to do it again in parallel to the P2, and doing it in order to achieve at the end a total loss of not more than 250 microns. So this is the technical objectives. And to do so, we are collaborating in a sub-consortium of 4 partners. The first one is Multitel. Multitel is a multi-sector applied R&D center dedicated to the applied photonics, image and speech processing, railway certification, networking engineering, human-machine interfaces. It was created in 1995. It has 70 people in this moment, and is located as well in Belgium. Their role in this assessment is to develop the laser source, so it's the main first part in the laser system. So they are developing the high-energy pulse laser with the capability of frequency doubling, so it's working in infrared and in grain in a controlled way. They will also contribute in finding the best laser configuration for the film processing, and collaborate with us, with LASHARE, in the integration of their laser source into the machine. As I said before, LASHARE is an engineering SME doing laser engineering. I'm not repeating. We were created in 1999. We are 39 people now, and we are located in Belgium. Our role in this assessment is the integration of the laser source provided by Multitel into the machine that will be the demonstrator at the end, with their support, of course. And after that, we will find the best choice of parameters in collaboration with Multitel and Cartif, the other partner. And we will assess SSE, the end user in this sub-consortium, in the use of the machine for their validation. That is their main role. SSE is a university spin-off founded in the 2000 year, whose activity is the technology transfer of polycrystalline thin-film solar cells, cadmium tellure, and jigs. They do R&D in those materials, and well, they have a production based on cadmium tellure already working in this moment. Since the year 2012, their modules are certified, and they are located in Italy. And their role in LIAS as an end user is to supply the materials to be processed, to optimize the processes and adjust the machine, and at the end to validate the laser process itself with the demonstrator we are developing in an industrial environment to really demonstrate we are passing to a TRL 7. And the last partner, not less important, is Cartif. Cartif is a multi-sector applied research center. They do automation, robotics. They work on ICT, energy and environment, and agri-food. In the year 2013, they were 170 staff people and were running 126 projects and with an income of almost 10 million euros. That is nothing but due to the situation in Spain. And they are located in Spain. Their role in the LEA is to work on lasers and machine parameters assessment and to collaborate in the installation of the laser system at the SSE facilities and collaborate in the production of production environment validation to assure that TRL 7. And that's all I have to tell you. Thank you.